This is the solutions to the end of module on inequalities. Okay, question number 1. N is an integer. Integer is the mathematical word for whole numbers. So n is a whole number satisfied by this inequality. For part A, we've got to write down all the possible values of n. The inequality tells that n is bigger than minus 3, but it is less than or equal to 1. What possible whole numbers are less than or equal to 1, but bigger than minus 3? Well, 1 is equal to the upper end, so that's fine. The next whole number is 0, when minus 1. Minus 2 is less than 1, but bigger than minus 3. We can't include this number because the inequality has got to be strictly bigger than minus 3, but it can be equal to 1. Okay. Part B, we've got to solve the inequality. We solve an inequality in exactly the same way as we would solve an equation. So something take away 7 is 11. What is it? The something is 18, because 18 take away 7 is 11. So that thing there, which was hidden by my finger, must be worth 18. Now, 3 lots of my missing number is 18. What's my missing number? My missing number is 6. Exactly the same method for solving an inequality. 18 take away 7 is 11. So 3p must be greater than 18. Therefore, p is greater than 6 is a solution. The difference between the equation and the inequality is that in this case there is one single value for p, and that is the value that when you multiply it by 3 and take away 7, it gives you the answer 11. The inequality is asking you to find all values such that when you multiply them by 3 and then subtract 7, give you an answer bigger than 11. So for example, 7 is one of the numbers that when you times it by 3, you get 21. Take away 7 gives you something which is bigger than 11. 8 would work and so on, but there is an infinite number of values that when you times by 3 and subtract 7, you get something bigger than 11. We can't write them all down, which is why this inequality notation is so useful. Anything bigger than 6, when you multiply it by 3 and subtract 7, you get an answer which is bigger than 11. Question number 2. We need to represent this inequality on the number line. So n is less than or equal to 3, but n is bigger than minus 2. Right? N can be equal to 3 because of that symbol. So we need to use a solid circle at 3. N can't be equal to minus 2 because we've got the strict inequality. So we need a hollow circle at minus 2, and then we need a line joining them up, because n can take any value in that range. Okay, 2 part B, solve the inequality. Again, think of it as an equation. How would you solve this equation? This equation is different and more difficult than the previous one because it has letters on both sides. It's not a number multiplied by something, take away something equals a value. You've got an unknown on this side as well as this side. What we've got to do is we've got to get rid of that thing which makes it complicated. But now this is unbalanced. We have to balance things up by, if we've removed 6x from this side, we need to remove 6x from the other side as well. And that leaves us with 2x on the left-hand side, minus 3. We've just got 4 on the right-hand side. Now this looks exactly like the previous one, and we can solve it in the same way. Something take away 3 is 4. The something is 7. So 2x is bigger than or equal to 7. Something multiplied by 2 is 7. What is it? It's 3.5, but the easy way to do it is to divide through by 2. You can write your answer as x is bigger than or equal to 3.5, but leaving it as the improper fraction is fine. Question number 3. Again, write down all the possible values for m. So m can be equal to 3, but it can never be equal to minus 2. So there are the 5 integer values that the inequality can take. Part B, very similar method to above. Get rid of the 3x, so we've got to take away 3x on the left hand side to keep things balanced. Something take away 9 is 4. What's the something? this must be worth 13. Divide through by 4. That's not going to simplify nicely, but to leave it as the improper fraction is fine. And finally, question number 4. Again, same idea. List all the possible values for the integer n. We start at -1. But we've got a strict inequality on the right. We can never be equal to 4. So we stop at 3. Write down the inequality shown in the diagram. We can be equal to 3 because we've got a solid circle, but we can never be equal to -4 because it's a hollow circle. So make sure you get your correct symbols. And finally, part C, solve the inequality. Something take away 2 is 5. Something must be 7. Divide through by 3. Again, 7 over 3 won't simplify nicely, so leave it as the improper fraction.